I think we did it. I think we did it. Who do I have? I got Kevin and Omar.
Yep.
All right, cool. So I consider this a very, very important lesson. Um, so I took your test and I took your like your practice quiz, and they're almost identical. So I'm hoping that's the case when the test actually opens for you. Again, I didn't write this course, but it looks like they're nearly identical. And I feel like the last 7 questions are worth going over. First of all, let me ask a basic question. Do you, Kevin, and Omar, do you know how to solve systems of equations problems?
I think I'm doing all right. I definitely had during the problem set, I was having definite problems doing the inequalities. Um, I
Okay.
guess I'm just it just I just was drawing a blank, and I feel like maybe you could explain it better than the
11 through
Pearson.
17 are challenging. So the first thing I want to do, what about you, Omar? Do you know what systems of equalities are, or systems of equations? Do you know what that is?
Negative.
All right. So a system of equations is more than one equation.
Okay.
That's all it means. So when we solve one linear equation, I'm going to pull up, I'm going to share my screen. I'm going to try to give you a basic idea of what we're talking about here. So share, let's see. So you can see my screen right now.
Yep.
Yes.
All right. So I'm going to show you some stuff in Desmos. All right. First of all, when we solve an equation, let's say we have something like y is equal to negative 3x plus 2. Right. So that's a straight line. Hold on. Just going to get out of these giant numbers here. All right, so that's a straight line with a y-intercept at 2 and a slope of negative 3. So the reason that we graph is because there's an infinite number of solutions. There's an infinite number of ordered pairs. There's an infinite number of x and y values that serve as a solution to this equation, right? If I throw a 0 in here for x, I'd get a 2 for y. If I throw a 1 in here for x, I'd get a negative 1 for y. There's an infinite number of these of solutions. So the graph is a picture of all those solutions. That's why we graph. It's a picture of all the solutions. So what if I had another line, like let's say y is equal to 2x minus 2, something like that. All right. So now I have 2 lines, right? So how many solutions are there that will, if we plug them into both of these equations, will make both of these equations true?
1.
1, right here. That's it. So when we solve an equation, we draw a straight line, and then that straight line is the solution. The picture of the linear equation is the solution. But when we have 2 linear equations, we have just one solution if the 2 lines cross, right? If the 2 lines cross, we have one solution. Now, if these both had the same slope, they'd be parallel lines. There'd be no solution. Or there's a possibility if they were multiples of one another. Hold on. 2y is equal to negative 6x plus 4, right? So if they're multiples of each other, they'd be the same line. So when we're solving a system of equations, there are 3 possibilities. The 2 lines cross. The 2 lines are parallel. So when they cross, there's one solution. the two lines are parallel. When they're parallel to each other, there are no solutions. And then the third situation is when the two lines are simply scalar multiples of one another. These two lines, the only thing separating these two lines is if you multiply the first line by 2, you get the second line. And they're the same line. So there's an infinite number of solutions. All right. So one of the things that's challenging about this test is we're going to be doing these problems that are objective function problems, right? This is called linear programming. And it's really, really interesting how linear programming is used. Like, I'll show you a couple of examples. But in order to be able to solve a linear programming problem, you have to be able to solve a system of equations. So let me take a look at this practice quiz.
How you doing, Professor? It's Weatherby. I just joined.
Oh, good. Good. I'm glad you're here.
Yeah, I don't know. It was taking me a little bit to join for some reason, but I'm here.
Yeah, I'm recording it also. So,
okay.
All right. So what do I need to do? Internet. I'm going to go into, we're going to do problems 11 through 17 from the practice quiz, which is basically a test review. And I'm going to, I think they're the hardest problems on the test. So that's why I wanted to take some time to go over this with you, because I want to see everybody do well. All right, so let me go into, no, I want to go in as a student. All right, so now I'm going to go in as an instructor, because if I take a quiz, I can't check my answer. So I'm going to go in as an instructor, and we'll preview the quiz through my end. All right, so that would be practice quiz 2. So practice quiz 2 is basically the test, right? If you're comfortable with practice quiz 2, you're going to be comfortable with the test. So here's where I want to start. I want to start with problem number 11, right? And in problem number 11, we're asked to solve a system of equations. All right, so what does solving a system of equations mean? It means we're going to graph these two lines, and we're going to see where they intersect. So I could here, I'm going to write this down. I've got x plus y is equal to -9, and x minus y is equal to 7. So we have two equations. Now, let me ask you, can you see my notebook?
Yes, I can.
Yep.
All right, cool. So I can toggle back to that. Let me hit auto zoom, auto focus. All right. So I can toggle to the notebook and you can see that fine. All right. So what I'm going to do is I'm going to show you what this system of equations looks like if it's graphed, right? So we have x plus 9, x plus y equals -9. And we have x minus y is equal to 7. That's supposed to be y. All right, so what does solve a system of equations mean? It means find this point right here, this intersection point, right? That's what it means. We want to find that point right here. Now, clearly, when I put it into Desmos and I click on it, it gives me the solution. It tells me that -1, -8 is the place where these two lines intersect. So what does that mean? That means if I plug x equals -1 and y equals -8 into both of these equations, that's the only ordered pair that will make both equations true. Everyone follow me on that?
Yep.
Yes, that makes sense.
Okay, cool. That's a good place to start. All right. So, what is the addition method? All right. So, when we're talking about algebra, there's basically a very simple truth in algebra is if we have two unknowns, we have too many unknowns, right? So the strategy in algebra is to try and figure out a way to only have one unknown. I'm only going to show you one way to do this because it's only necessary to show you one way, and time is an issue, right? But there's a method called the addition method. And with the addition method, the basic strategy is you want to either get rid of x or get rid of y, okay? And you want to add the two equations in your system together in such a fashion that one of the variables will cancel out. So if you look at this system right here, notice that in equation 1, and I will always number my equations when I'm doing systems of equations. In equation 1, I have a plus 1y or a plus y. And in equation 2, I have a -1y. So what does that mean? That means if I add these two equations together, the y is going to drop out. And when we're using the addition method, our exact objective is to make one of the variables drop out. Like, let's say, for instance, I'm going to make something up. And I'm not going to solve it, but I'm going to just make something up. All right, so here's a new system that I just made up on the right-hand side. If I add these together, will a variable cancel out?
No.
No, it will not. But in algebra, we're allowed to do whatever we want to one side of an equation as long as we do the same thing to the other side of the equation. So in this particular situation, what I would do is I would multiply equation number 2 by -2. If I multiply the second equation by -2, well, I'm going to rewrite equation 1. Equation 1 is 2x minus 3y is equal to 2. And now if I multiply the second equation by -2, that's going to give me a -2x minus 4y is equal to -8. Everyone see what I did there? I just want to cancel a variable. That's all I want to do. I want to cancel out a variable. And sometimes, like in this example from question 11, they're going to give you two equations that if you just add them together, a variable will cancel. Like, look here. If I add these together, I get 2x. This is going to cancel. A positive y and a negative y, they're going to cancel. That's the exact objective. So if I add these together, I end up with 2x is equal to -2. And then if I solve for x, I get x is equal to -1. So what I have found is the x part of the ordered pair that will make both of these equations true. Right? And look, this is what we got from Desmos over here. Right? I'm going to pull Desmos back up. That's not Desmos. Look, -1. Everyone with me so far? I know this is challenging.
Yes.
Yep.
Okay,
Yeah,
good.
copy.
Now, I know what x is now. I can take that x value and plug it into either equation 1 or equation 2 to get my y value. So if I plug, let me pull this back up again. If I plug x equals -1 into equation 1, I'll get -1 plus y is equal to -9. And then if I add 1 to both sides, I get y is equal to -8. That is how you solve a system of equations.
That's cool.
Okay? That's how you do it. You got to get one of the variables to cancel out when you add them together. And then solve for the one that didn't cancel out. And then use the value from the one that didn't cancel out to back substitute into one of the equations to get the value of the other variable. And you'll notice that this exactly matches what we got when we plugged it into Desmos. Are we cool so far?
Yep.
Good?
Yep, we're good.
All right. So now, the question at hand. Well, we already solved it. Solve the system of equations by the addition method. I'm wondering if they want parentheses here. Like they give us curly brackets.
They do.
They do?
Yep.
They give us curly brackets, but an ordered pair is really supposed to be in parentheses. So let me check my answer. Okay, so that's problem 11. That's solving a system of equations by the addition method. What are we doing when we're solving a system of equations? We're looking for the place where the two lines intersect. Good?
All good.
All good?
Yes.
All right. All right, so they're saying solve the system by the method of your choice. Well, I didn't give you another method because, again, time is of the essence. We're not going to use the substitution method, but excuse me. Let me show you something else. This is known as the general form of a line. Pardon me. All right. So when we're solving a system of equations, we want it to be in this form. You've heard of slope-intercept form. You've heard of point-slope form. When we're solving a system of equations, we want it in this form. So when we have something in general form, if we wanted to graph this, the way that we graph something that's in general form is we just find the intercepts, right? How do you find a y-intercept? You let x equal 0. How do you find an x-intercept? You let y equal 0. So one of the things we're going to be required to do in these last 7 questions is we're going to be required to graph some things. So I'm going to take a look at this problem again. We've got x plus, so here's our system. This is problem number 12. So here's our system. We have x is equal to 5 minus 4y. And we have x plus 4y is equal to -8. So this is not what we want this to look like. right? This is not in general form. So all we want to do is we just want to move the X's and the Y's on the left and the constant on the right. That's what general form means. Put the things with variables on the left and the constant on the right. So that's all we want to do. So it looks like the second equation is already in general form. So that's fine. So what I want to do now is I want to take the first equation and I want my X and my Y on the same side. So if I add 4Y to both sides, I'll end up with X plus 4Y equals 5. Is everyone good on what I did just there?
Yes.
Yeah, I'm tracking.
Everyone understand how I got from here to here?
Yep, you added for Y.
Hold on. I just added 4Y to both sides so I could get this in general form. So now, oh, this is an interesting problem, right? These are parallel lines. These are parallel lines. How do I know they're parallel lines? All right, so let's use the addition method, right? And now you notice I have X and 4Y and 4Y. So let's say I multiplied this bottom equation by -1, right? So I get X plus 4Y is equal to 5. And then I get -X minus 4Y is equal to +8. So all I've done is I want one of these variables to cancel out. But notice that they're the same. So if I cancel this, I get a 0 plus a 0 equals 13. This is not true. These must be parallel lines. And let's go to Desmos and take a look. So I've got X plus 4Y is equal to 5. And X plus 4Y is equal to -8. Oh, they're parallel lines. So that's how we know graphically. We can just graph them and look at them. They're parallel. How do we know analytically? If we solve the system of equations and we get a statement that's not true, this is not true, this can't happen, that means parallel. There's no solutions. When we solve a system of equations, as I mentioned earlier, we have 3 scenarios. There are 2 lines that cross. That's one solution. There are 2 lines that are parallel. That's no solutions. And there are 2 lines that are exactly the scalar multiples of one another. That is an infinite number of solutions. So in problem number 12, what's my answer here? A, B, or C?
No
C?
solution.
No solution. C. So in problem 11, you have to know how to solve a system of equations. In problem 12, you have to know how to solve a system of equations. We'll use the addition method to do that, which means we want to have 2 equations where when we add them together, one of the variables is going to cancel out. All right, now let's look at problem number 13. All right, I think Kevin was saying that like these give him trouble. I've been teaching this for a lot of years, and this doesn't just give Kevin trouble. This gives a lot of people trouble But I'm going to show you a trick that I genuinely believe you won't have any issues with this after I show it to you, right? So we're asked to graph an inequality. So what the heck does that mean? All right, so we're asked to graph the inequality, and I'm going to say, let's see, 7x, what's that? 7x minus y is less than or equal to 14. So let's switch back over to my paperwork. So this is problem number 13 here. So we're asked to graph this, right? So there's a couple things about graphing an inequality. You're not graphing an inequality for starters. You're graphing a line. So you start by graphing a line. And the line that you're going to graph is 7x minus y is equal to 14. So you start by graphing a line. We'll worry about the inequality part of that later. So this must be in slope-intercept form. This is very important because this whole idea of using a test point, it's very confusing. But what I'm about to show you is much less confusing. So in order for you to use this technique, I have to put 7x minus y equals 14 into slope-intercept form. So how do I do that? I need a y by itself on the left-hand side. So, well,
Ok, exagerado, tú eres como sea.
Friday outside. Bueno, me quería, yo había pedido estos dos, eran 20, and the free upside, it was this one. Entonces me quedé,
what is that?
Never mind.
So the first thing I want to do is I want to rewrite this inequality until it's in slope-intercept form, right? So if I rewrite this inequality, the first thing I'm going to do is I'm going to subtract x from both sides. If I subtract x from both sides, that's going to be negative y is less than or equal to, or I'm sorry, not x, negative 7x plus 14. So that's my first move. I'm trying to get y by itself. Now, the next thing I need to do is I need to multiply both sides of the inequality by negative 1. But remember, if you divide or multiply an inequality by negative 1, you have to flip the inequality sign. So if I do that, I'm going to get y is greater than or equal to 7x minus 14, right? So the line that I need to graph is y equals 7x minus 14. All right, so let me recap what we're doing here. We're asked to graph an inequality. The way that you graph an inequality is by graphing the line first. But we have to put the inequality into y equals mx plus b form, right? Before we could graph anything. So we put the inequality in y equals mx plus b form. That's here. Now, we just want to graph the equality, the equation y equals 7x minus 14. So let's go ahead and look at this. How do we graph y equals 7x minus 14? Well, we can put it in, it's already in slope-intercept form. So what is my slope? Here's what I'm graphing. What is my slope?
Negative 14.
That would be my y-intercept.
Right.
What is my slope?
7x.
All right, so let's take a step back for a moment. All right, let's take a step back for a moment. When we have something in the form y equals mx plus b, what this is telling us is that this part right here, the coefficient on the x term, that is my slope. And the slope m is equal to the change in y over the change in x. Or another way to put it is rise over run. So this tells us like just how quickly my line goes vertical versus horizontal. So that is my slope. What does this tell me? What does B tell me?
That's the y-intercept.
That's the y-intercept, right? Or more specifically, it's the y value of a y-intercept. Every y-intercept has an x value of 0. It's how you find a y-intercept is by setting x equal to 0. So when we have something in slope-intercept form, we know what the slope is and what the intercept is. And we can use the slope and the intercept to graph. So what is my slope in question number 13?
7.
7. Or another way we could say this is it's equal to 7 over 1. And what does that mean? That means up 7, right 1. So if we have 1 point and a slope, we can graph something. What is my y-intercept?
Negative 14.
It's negative 14. So my y-intercept is the point 0, negative 14. That's all that we need to graph this equation. When we put it in slope-intercept form, it shows us the slope, it shows us the intercept, and we could graph. So I'm going to go ahead and click here, right? And I'm going to click the line tool, right? And the first thing I'm going to do is I'm going to enter my y-intercept, and that's going to be the point 0 minus 14, all the way down there. My slope is 7. That means go up 7 to minus 7, and then go right 1. So that is the graph of the line y is equal to 7x minus 14. So what did we do? All right. So what do we do here? Well, we have 7x minus y is less than or equal to 14. We're asked to graph that, right? So, but really, we're going to be graphing a line, right? So the first thing we do, I'm going to cross this out, right? Because we're not even starting by graphing a line. We're starting by putting the inequality in slope-intercept form. That's actually our first step. We're going to put the inequality in slope-intercept form. Once we have it in slope-intercept form, we're going to graph the line that we're not graphing the inequality, we're graphing the equality, right? So y is greater than or equal to 7x minus 14. That's our inequality. When we graph it, we're just saying, okay, y is equal to 7x minus 14, right? Now, there's another thing we have to consider, okay? If we have less than greater than or equal to or less than or equal to. That means it includes the line itself. This includes the line y equals 7x minus 14. So it's not just everything above that line, it's also that line. So how do we represent that the line itself is included? We make sure it's a solid line. If we have greater than or less than, this does not include the line. In that case, we use a dashed line. So in this problem right here, we have y is greater than or equal to 7x minus 14. So that means it includes the line. That means we're going to make the line solid, right? If it didn't include the line, I would click this dash button and I'd make the line here. Let me click on the line and then click the dash button. So when it's dashed, that means I've got less than or greater than. When it's solid, that means I've got less than or equal to or greater than or equal to. Is everyone clear on that?
Yes.
Yes, that's clear.
Oh,
All right. So now, and this is the trick, right? We're looking for where this is, y is greater than or equal to 7x minus 14. This line splits the XY plane into two regions, right? So I'm going to click this paint brush right here, this paint can. It clicks it into two regions. I've got this region over here. And I've got this region over here. Everyone with me on that?
Yep.
Okay.
Yeah.
So I got to figure out which region to populate. Well, on this left-hand region here, would you say we're above or below the line?
Let's see, we're
Below the
above.
line.
We're above, right? This left-hand region, we're above the line. This right-hand region, would you say we're above or below the line? Look, if I'm standing right here and that line is an umbrella, I'm not getting wet. So the left-hand region, we're above. The right-hand region, we're below the line. Everyone with me on that?
Yes, that makes sense.
So above the line's greater than, below the line's less than. You follow me?
Yeah, that makes sense.
Let's do another one. If I can do another one. I guess it's not letting me. Well, let's see how we're doing on time, because we're not even to the hardest stuff yet, right? That's why I felt it was so important for us to have this extra session. Now we're being asked to graph a system of inequalities. It's just this section just gets progressively harder and harder, right? So we had to solve a system. Here, let's just back up for a second. We had to solve a system by the addition method. Then we're asked to solve another system by any method. Then we're asked to graph an inequality. And now we're asked to graph a system of inequalities. Okay, so let me ask you this question. I'm going to write this system down. So I've got y is greater than -2x plus 8. I'm going to call that equation 1. And then I've got y is less than x minus 3. I'm going to call that equation 2, right? So here we are. Is equation 1 in slope-intercept form?
Yes, it is.
Okay.
Yeah.
And what is the slope of equation 1?
Negative 2.
Negative 2. And what is the intercept?
It's that 8.
Okay. Now, my next question is this. Is equation 2 in slope-intercept form?
Yes, it is.
Yes, it is. What is the slope of equation 2?
1.
1.
1. And what is the y-intercept of equation 2?
Negative 3.
Negative 3. That, my friends, is all the information that you need to graph a straight line. Right? A slope of negative 2, okay, means go down 2 and right 1. Or you could do it like this. You could go up 2 and left 1. Just as long as only one of them is negative. If they're both negative, it's positive, right? So when you have a slope of a negative 2, that either means down 2, right 1, or it means up 2, left 1. How do you make that decision? I don't know, flip a coin, see how close to the top of a graph one of them is going to take you, but just make sure that you're going in opposite directions. And the other one is a slope of 1. So slope of 1 means up 1, right 1. Everyone clear on that?
Yep.
All right. So how do you graph an inequality? You don't. You graph an equality. Now, let me ask you my next question. When I plot these lines, am I going to use a solid line or a dashed line?
Dashed.
Dashed. I'm going to use a dashed line. So let's go ahead and use that information that I just wrote down. That's obvious by the fact that this is slope-intercept form. Let's go ahead and use that information to plot these lines. So the first line is a slope of negative 2 and a y-intercept of 8. So I'm going to go plot my y-intercept first, and I'm going to count down 2, right 1. Then I'm going to make sure it's dashed. That's it. That's your first line. Now, my second line has a y-intercept of negative 3. So I'm going to click at negative 3, and this has a slope of 1. So I'm going to go up 1 and right 1. Now I'm going to make sure it's dashed. Okay. That's it. Now, here's the hard part, right? Where is y greater than negative 2x plus 8? Y is greater than negative 2x plus 8 above this line. Everyone follow me on that?
Yeah, that makes sense.
But now we have 2 lines. It splits it up into 4 regions. So where is y less than x minus 3? Well, y is less than x minus 3 here and here. What do they have in common? That's the question. It's just that region. It has to be where we're above the first line and below the second line. The only place we're above the first line, that's these 2 regions, and below the second line, that's these 2, is right here. You follow me?
Yeah, that makes sense.
So this is kind of where I was getting tangled up. So when it's saying y is greater than negative 2x plus 8, it's just asking if it's above or below the line. I guess I'm
That's exactly correct.
so
So
the
where's
line
y greater than negative 2x plus 8?
right. Yeah.
The-
So
Up there, above
y
the
is
line.
just the variable y is basically just representing the actual plotted line.
The variable y represents the vertical movement,
Okay.
right? So that's why we're concerned about above
Gotcha.
or below, because y means up or down. X means left or right.
Gotcha. Okay.
You got me?
Yep. I'm tracking.
So what if I asked you, where's y less than negative 2x plus 8? Well, y is less than negative 2x plus 8 below it, right? So that's not what I was trying to do. All right, well, that's okay. We just have this one line right now. So this line represents y equals x minus 3. So below y equals x minus 3 means underneath the line. So that's less than. Less than is underneath the line. If that were greater than, then we would populate this area in here. So what was the other line? It was y is greater than negative 2x plus 8. Let's put that line back in. Let me delete this paint can. And let me put that line back in. So we have the line negative 2x plus 8. So that means I've got a y-intercept here. I'm going to go down to right one. I got to make sure it's dashed because that's a greater than sign. And then the area where that's true for both is right there. Let's check our answer. We're looking good. So there is another way to do to figure out what quadrant you're in, which of these four regions you're in. But I think that way is much harder. You can actually select a test point, right? So in other words, if we wanted to verify that we're in this quadrant right here, this yellow area, we could just pick a point that's in the shaded region. Like for instance, the point 60. Like we know the point 60, which is problem 14, right? So we know the point 60 is in the shaded region. Well, is that the right region? Is that where we're supposed to be? Well, I can just plug it back in to this and this, right? If I plug 60 into these equations and they're both true, then I've selected the right region. So I could say, well, x is equal to 6, y is equal to 0. So is 0 greater than negative 2 times 6 plus 8? And that brings me to, is 0 greater than negative 4? This is true. So that's for equation 1. Now, equation 2, I'm going to say, is 0 less than, and then this would be 6 minus 3, which would be is 0 less than 3, and that is true. So we have, in fact, selected the right region because all the values in that region, when plugged back into the original equations, will make them both true. I think it's much easier because now you got to be like, okay, I think it's in this region. I'm going to pick a point. And, if you guess the wrong region, your point will be wrong. Now you got to pick a point from a different region. I personally believe it's much easier to just envision this. If you put it into y equals mx plus b form, then we could just worry about whether we're above or below the line. Right?
Mm-hmm.
Does that make sense?
Yeah, I think the help me solve this was telling me to pick a point, and that's where I kind of like.
I don't particularly care for that approach.
Yeah.
You can pick a test point, right? Like here, let me just randomly do something here. We already know that this is accurate. So, what if I Here, I'll write an equation. I'll write y is equal to, now I'll say greater than or equal to negative 2x plus 3. Y is greater than or equal to negative 2x plus 3. This is just an example, right? Y is greater than or equal to negative 2x plus 3. So how would we graph this? Well, we just graph y is equal to negative 2x plus 3, right? So let me go ahead and graph that. So I'm going to go back. I'm going to graph y is equal to negative 2x plus 3. That's a y-intercept of 0, 3, and negative 2 means down to right 1. All right, so that's y is equal to negative 2x plus 3. Now, this is greater than or equal to, so we want a solid line, right? But what if I wanted to not, like, to me, it's very clear to say that y is greater than, well, y is greater than above it in here, right? But let's say I wanted to use a test point, okay? I can pick a point from either of these regions and test that point. So let's say I wanted to, okay, 0, 0 is a nice, easy number to work with. I'm going to test 0, 0. So if I test 0, 0, I'm just going to replace y with 0, and I'm going to replace x with 0, and see if it's true or false. So this is y, 0 is greater than or equal to 3. This is false, okay? So what does that mean that it's false? It means I picked the wrong region. If I pick this point right here at 0, 0, and it's false, it's got to be the other region. But again, I personally think it's easier to put these in y equals mx plus b form. And then just determine, am I above or below the line? So you can use either strategy, but I feel like this strategy is the easier and by a lot. The test points can get very confusing. So are we good so far?
Yeah, absolutely.
Everybody's feeling okay? Omar,
Yeah.
Weatherby,
Yes.
Yeah, I'm feeling good. I'm gonna
Alright.
have to go soon, but you said this whole thing was recorded, right?
yeah. And
Yeah,
then
I
it's
gotta
just
go.
a matter of me figuring how to find the recording and email it.
Okay.
I'll probably wait for the boss to get home to do that. She's a little bit more tech savvy than me. I'm just math and music, man. Those are the two things I'm good at. All right, so now these last three problems I think are very, very challenging. Actually, one of them's not, but so
Yeah,
you're
I gotta head off to
definitely,
work, but yeah, thank you. Thank you for this, and I'll catch a video.
yeah, no worries, man. All right, so this problem, hold on a second. Can everyone see this problem?
Yeah.
All right. So we're given an objective function, and we are given constraints. Okay. And I actually recommend, I don't have time to do all this. I'm not trying to teach you theory. I'm just trying to teach you how to solve problems, right? I'm trying to teach you how to solve the problems that are on your test. But seriously, go into the textbook and watch the little 3-minute videos. I did it last night. They're awesome. It's really interesting. It's like these objective functions were how we were able to, get through the Berlin blockade in World War II. Like, it's really fascinating stuff, right? But I'm just trying to teach you the problem. So go into 7.5, watch those videos. Like when you go into the textbook, they have like little 3-minute, 4-minute videos that you can watch on each section, and they're really interesting and they're really helpful. So we're given an objective function and we're given constraints. All right. So how do we solve this problem? Okay, I said it's a hard problem, and it is, but it's not a super hard problem, right? So how do we solve this problem? First of all, we have to graph this stupid thing, right? We have to graph all of these constraints, because what these constraints are going to do is they're going to fence off an area, and that area represents the region of where our solution lies. So I'm going to graph x is less than or equal to 3. Well, anytime x is equal to something, that's a vertical line, right? So x is equal to 3. Look, it's 3 here, it's 3 here, it's 3 here. That's what x equals 3 means. It's just anywhere I go in the y-axis, x is equal to 3. And then that's got a less than or equal to. So that's going to be a solid line, right? And what's less than 3? We're only talking about x now. So less than 3 would be the region to the left of it. Everyone with me so far?
Yes, sir.
All right, I'm going to get rid of that paint can because we still have 2 more lines to graph. And we're interested in the fenced in area. Okay, what about y is greater than or equal to 3? So that's y equals 3. That is simply a horizontal line. So y equals 3, y equals 3, y equals 3. That's my line, right? Now, the third line is not in slope-intercept form. So we need to put that in slope-intercept form. We're not using that test point strategy. That gets nightmarish, especially when you look at problems like this, right? So let me flip over to my InSwap, right? So we want all of these constraints. We want all these constraints to be in slope-intercept form. The first 2 are fine. 1 and 2 are fine, but 3 is not. So our objective is to put this in a slope-intercept form. And if I do that, I'm going to get negative y is greater than or equal to negative 2x minus 3. But now I have to multiply both sides by a negative. That means I have to flip the inequality. That's going to give me y is less than or equal to 2x plus 3. So this is equation 3. We got 1, we got 2, and now we have equation 3 in slope-intercept form. What is my slope?
It's 2.
And what is my intercept?
3.
Okay. So here's 3. That's my intercept. And my slope is 2. So I go up 1. I go up 2 and right 1. Okay. So now look, that's the fenced off region. I'll put a little paint bucket in there. So that's our fenced off region. Our answer lies somewhere in there. Is everyone with me so far?
Yeah.
Yes.
Okay, so our answer is somewhere in that fenced off region. But there's only a finite number of places where our answer could be. It's not in the middle. It's at one of the corners. This is known as a really interesting and incredibly challenging field of mathematics known as optimization, right? We know that our answer is at one of those 3 corners. You notice that we have a triangle there. In fact, we have a right triangle. So our answer will lie at one of those 3 corners. So I'm going to go ahead and show you so that first corner right there, I'm going to call that A, the bottom left, and then the top one I'll call B, and then the bottom right I'll call C. Can you tell me what the coordinates are of that first corner, that bottom left corner?
Zero.
2, 0. Or
So
0,
2 first means you're heading along the x-axis first. So I'm not traveling along the x-axis. I'm on the y-axis. So my x value will be 0. And then I go up 1, 2, 3. So that first point A, would be 0, 3. Everyone with me on that?
Yes.
Yeah, I'm sorry. Yeah, I got it.
It's very easy to mix them up, right? I even do it occasionally. But remember, the x value goes first, the y value goes second. All right. So that was our first point, which we call point A. What's our second point up top here? What are the coordinates of that point?
To be 3, 9.
3, 9. That is correct. And then our third point is down here. What are the coordinates of our third point?
3, 3.
Let's see. 1, 2, 3. Yep, 3, 3. All right, so we've got 0, 3, 3, 9, 3, 3. All right, so I'm going to flip back over to my INSWAN. All right. So, what was the objective function? Anyone write that down? Let me go back and grab it. So the objective function is z equals 3x plus 4y. So z equals 3x plus 4y. That's my objective, right? My constraints and my objective. All these problems are going to have an objective function and then some constraints that will tell you. Pardon me for 1 second. Excuse me. All right, sorry about that. All right. So here's our objective function. Z is equal to 3x plus 4y. Here's our constraints. We use our constraints to fence off a region. And the region that we fence off looks like this in this particular problem. And we know that our solution is either here or here or there. If we're looking for maximums and minimums, that's why it's called optimization. When you're doing optimization problems, you're looking for a maximum or a minimum. So what we have to do, again, objective function is here. Constraints here. The constraints give us our fenced off region. We determine what the points are, the corners of that fenced off region. And then what do? We figure out what z is equal to given this X value, that Y value, right? The left-hand side is X's, the right-hand side is Y's. So for A, I've got X is equal to 0, Y is equal to 3. So this becomes Z is equal to 3 times 0 plus 4 times 3 is equal to 12. Everyone with me on that?
I'm sorry. Yeah, I'm with you. I'm sorry. I had them mixed up. I did the same thing I did earlier.
Omar,
I'm tracking.
you're
You just
tracking? It's challenging, right?
you starting with A and going down to find out what the C.
Yeah, what I'm trying to do is I'm trying to find out what the value of the objective function is for the 3 points that represent the possible places to find a max or a min.
Right, the
These
constraints.
3 points, right? The corners. So I'm looking, I'm trying to figure out what is Z equal to? What is Z here, and there? That's what I'm trying to figure out. What is Z at those 3 places?
Okay.
Does that make sense?
Right, and we now just find out that A is 12.
So yeah, so if I plug 0 and 3 into the objective function for X and Y, I get 12, right? Now let's take a look at B. So at B, I've got X equals 3 and Y equals 9. So this would be 3 times 3 plus 4 times 9. And that's going to be equal to 9 plus 36. That's equal to 45.
Right.
You with me?
Yep.
Yes.
And then for C, my objective function is going to be equal to, so they're both equal to 3. So this would be 3 times 3 plus 4 times 3. That's going to be 9 plus 12 is equal to 21. So where's my max?
45.
45. Where's my min?
12.
21. Your minimum 12, yeah.
Yeah. That's the entire process, right? So they give you an objective function. They give you constraints. You have to graph those constraints. And then you have to evaluate the value of the objective function at each one of the possible critical points.
So what's the answer?
Well, let's find out what the question is first. So find the value of the objective function at each corner. Okay, so we got 12, we got 45, and we got 21, right? The maximum would be the biggest number. That would be 45. So the maximum value of Z is 45. And where does that maximum occur? That occurs at that top corner, right? That's 3, 9. You follow?
Yep.
This is challenging. The next one's worse. This is challenging stuff. Omar, you follow?
Yes, sir.
All right, let's check the answer. Fingers crossed.
Nice.
All right. Let's look at 16. So, this problem is like, I don't know how to put it. Every student's nightmare, something along those lines. However, I can tell you something right now. And this is a fact. I'm looking for something. Give me a second. I wrote it down in my notes. All right, so I'm going to show you my notes, right? When you're doing, let's see, Okay, that problem's actually pretty easy. When you're doing these problems, there's one of two possible problems that you're going to see. You're either going to see this one right here, and I can actually, this took me 2 pages to solve, by the way, where they tell you, you're delivering food and clothing to an area that's impacted by hurricanes, and they give you an objective function, and they give you your constraints. You actually have to figure out how to translate it from a word problem to a math problem. But there's only 2 of them. There's this one right here that is the food and clothing problem, and then there's the movie problem. So let's see. All right, well, let's do the problem at hand, because I'm fairly certain that that's the one you're going to get on your homework. I mean, on your test, right? So I'm going to start with a clean page here. This is easily the hardest problem of the semester so far, right? So a theater is presenting a program on drinking and driving for students and their parents. The proceeds will be donated to a local alcohol information center, right? So look at the actual question. To raise the maximum amount of money, okay? So what does that mean? That means our objective function is going to be z equals something, and we're looking for money raised. We're trying to maximize money raised, right? So now the mission is $12 for adults and $6 for students. So we're going to just declare that X represents adults and Y represents students. So this is what I have written down so far. I'm basically identifying my variables, right? So we're looking for total money raised, and we have X as adults, Y as students. So they tell us admission is $12 for adults and $6 for students. So what they're doing is they're giving us the objective function. When you do these problems, they're going to give you the objective function first. So adults is X. So $12 for an adult means 12X. And Y is students, and $6 for a student is 6Y. So the total number of students plus the total number of adults and what they paid, that's going to be the amount of money raised, right? So this is what I have written down so far. Now, we have 2 constraints. The theater can hold no more than 150 people. All right, so what does that mean? That means X plus Y has to be less than or equal to 150, right?
Yep.
Right.
So this is what I have written down.
But it also says that there has to be a kid for each.
Okay, so now let's move on to the next constraint. Now this one gave me a lot of trouble. Okay, I got to be honest with you. This one gave me a lot of trouble. It says there must be at least 1 student for every 2 adults. I had to do a little bit of trial and error to figure out how I was going to write that. There must be at least 2 adults for every 1 student. So, well, why is my students? So what I ended up coming up with was I came up with y is greater than or equal to x over 2. That was my first guess, was y is greater. I was thinking 2y, really, I was thinking 2y is greater than or equal to x. Right? Like 2 students has to be more than, or I'm sorry, yeah. So 2 times the number of students has to be greater than the number of adults. But what I did was this.
2x plus y.
So let me write so for every 2 adults there must be at least 1 student. So for every 2 adults there must be at least 1 student. I'm going to write that down. For every 2 adults, at least 1 student. So so at least 1 means greater than or equal to, right? So, and for every 2 adults, yeah, so that's what I did. I went like this. And then I divided by x over 2. But really, ultimately, what I did was I threw some numbers in there because this is super confusing to me, right? So I threw some numbers in there. I was like, okay, if I have 2 adults, I'd have to have 1 student at least. If I had 3 adults, I'd have to have, so let's go with it. Let's just say 6 adults. So let's say I had 6 adults, right? So if I got 6 adults, adults are X, I have to have at least
3 kids.
3 students, right? So if y is equal to 3, that's my students, then that's got to be greater than 6 over 2, right? So that's kind of like how I figured it out. I had to throw some numbers in there to just try to make that work. But ultimately, I came up with y is greater than or equal to x over 2. Actually, I came up with 2y is greater than or equal to x, right? But I came up with y is greater than or equal to x over 2. So that's what I came up with. Just throw some numbers in there. I mean, it's either got to be 2y is greater than or equal to x, or 2y is less than or equal to x, right? So we've got our constraints. We've got x plus y is less than or equal to 150, and y is greater than or equal to x over 2. So those are our constraints. Now, what do I want to do? I want to graph them, right? And I know I don't even need the left side of the graph. I'm not even sure why I drew it, because you can't have less than, you can't have 0 students or less than 0 students, or we really only need this, the top right quadrant of this, right? So if I graph this, let me just rewrite these. So I'm going to rewrite this in equation 1. I'm going to rewrite that in mx plus b form. So that would be y is less than or equal to negative x plus 150. And then the second equation is already pretty much in y equals mx plus b form, but I'm going to go ahead and say y is greater than or equal to 1/2 x. So all I did was I pulled a 1/2 out instead of an x over 2. Now I can graph these. So this is a slope of -1, and I'm going to put 150 up here, right? In fact, I'm going to put 150 here. So this is a slope of -1 and a y-intercept of 150. So that's a line that basically goes from here to here. That's a 45-degree line with a negative slope. And then my other constraint is it's got to be greater than or equal to 1/2 x. So that means I've got a y-intercept of 0. And I'm going to go up 1, right 2, up 1, right 2, up 1, right 2. So it probably looks something like this. All right, so now we have to figure out which of these 4 quadrants we're in. So where am I less than or equal to the first line? It's got to be either here or here. One of these 2 right here. That's below the first line. And then where am I greater than the second line? We're in here. We're in that region right there. Now, I have to find the objective function values at each of these 3 points. We got a point here, a point here, and a point here. I told you this stinking problem's hard, right? So what are the values of my points? Let's call this A, let's call this B, and let's call this C. So what is the value of point A? Anybody?
It's 0, 0.
0, 0. That's the easy one, right?
Yep.
What's the value of point B? See if you can get
It's
this.
0, 150.
Nice job. Now the hard one. How do I find the value of point C?
You find the intercept of the 2
75,
lines.
75.
Hold on, Kevin, what were you saying?
I mean, if you didn't, you just find the intercept of A and B, right? If you wanted it, if you didn't know the numbers.
How did we start today's lecture?
Finding the intercept of 2 lines.
By solving a system of equations.
Right.
Right? In order for us to find this point C, we have to solve the system. So what is my system? I'm going to take 1 and 2. I'm going to put them both in general form, right? So this would be x plus y is less than or equal to 150, and y is greater than or equal to 1, hold on. Negative 1/2 x plus y is greater than or equal to 0. It's a hard problem. But this is definitely on the test. So how do I solve a system of equations? Well, maybe I'll cheat a little bit here, right? Maybe instead of adding them, I'll just subtract them since I have a y and a y. So what's x minus 1/2 x? That would just be 1/2 x, right? A y minus a y would be equal to 0. That's why we're doing this. And then 150 minus 0 is equal to 150. So x is going to be equal to 300. If I did not make a computational error. Let me make sure I did not make a computational error. Negative 1/2 x. Oh.
It would be 75.
I made a computational error, right? This is x plus y is less or equal to 150 minus negative. This should be 3/2. I forgot to distribute this minus sign. That's why we use the addition method, right? So we don't screw up the sign. So that would mean that this is 300 divided by, so I multiplied both sides by 2/3. This is 100. Sorry, made a computational error. All right, so now x is equal to 100. Now we have to solve for y. Well, if x is equal to 100, y is equal to 1/2 x, which is equal to 50. So we have our third point. We have our third point. Our third point is 150. That's what this point is right here. All right. We're almost done. Okay, we're almost done. I know this problem's brutal, but if you do it 3 times, first of all, I'm going to give you 2 hints. Okay, I'm going to give you 2 hints. 1, C is going to be your max. And 2, if you get this problem, that's going to be the formula. So those are 2 huge hints. Right? If you get this problem, this is going to be your formula. Y is greater than or equal to 1/2 x. And the max is going to be here at C. All right, but let's finish the problem. So now we have A of 0, 0. So what's Z equal to when A is equal to 0, 0? Well, the objective function is 12x plus 6y. So that will be equal to 0. B is equal to 0, 150. The objective function is 12 times 0 plus 6 times 150, which is equal to 900. And then part C is we got 150. So Z is equal to 12 times 100 plus 6 times 50, which is 1,200 plus 300 equals 1,500. That's your max. All right, so let's see what the problem asks us. To raise the maximum amount of money, we need 100 adults and 50 students. Now, I'm going to say one more thing that might be a game changer. Who's paying more, adults or students?
Adults.
Adults. Okay? So maximizing the number of adults is going to maximize the amount of revenue, right?
Right.
There's got to be at least 2 adults to every 1 student. What do you think the number is going to be? One of the things I try to teach my students is to work smarter, not harder. Think about it, right? Think about it. You need the maximum number of adults. So if there's got to be 2 adults for every 1 kid and there's 150 people, you need a 2-to-1 ratio exactly. Does that make sense?
Yeah, but when I was trying to figure out what you were going to plug in the equation, I wrote 150 divided by 3, so that gives you the students.
Right?
Yeah.
I'm not saying every problem has shortcuts like this, but I'm saying work smarter, not harder. Just think about this problem. I need the most adults possible. That's a fact because adults pay twice as much. What's the most adults possible? It's 100. If the number was 300, then the number of adults would be 200. If the number was 450, then the number of adults would be 300. right? It's a 2-to-1 ratio is going to maximize your profits. Then you go with a 2-to-1 ratio, not a more students. You want the least amount of students to the most amount of adults. All right, let's do problem number 17. I got to get out of here because, like, I've been working since 9 o'clock this morning. I want to stop. All right, a football is thrown by a quarterback to a receiver. Not if you're on the Eagles, it's not. Just kidding. All right, so a football is thrown by a quarterback to a receiver. The points in the figure show the height of the football in feet above the ground in terms of its distance in yards from the quarterback, right? And look, you see where that x-intercept is? Or I'm sorry, you see where that y, there is no x-intercept. You see that y-intercept?
Yes.
What's that tell us? It tells us this quarterback's about 6 foot tall, right?
Right.
All right, so find the coordinates of point A. All right, we need to take note of what these tick marks represent on the horizontal axis, right? Each tick mark is 4 yards. So point A would be an x value of 4 and a y value of 8. It's almost like this problem feels guilty about problem 16, and then it says, all right, let's give us a nice easy one and round it out. So interpret the coordinates. Well, remember, this is testing, like, look, that's feet, that's yards, right? You got to, this is at the end of the test. You got to keep your eyes sharp. When the football has traveled a distance of, that's yards down there. So this is going to be 4 yards. It is at a height of, now the height is in feet. So that's going to be 8 feet. And that's it. That's basically your test. We went over the first half of it last week or whatever, and we just went over the second half of it today. Just practice. Problem 16 is brutal. It is. I tried to give you some hints, on how to handle problems like that, but just practice. If you practice, you'll be fine. All right?
All right. Thank you for your time, Professor.
Y'all good?
Yep.
Appreciate it. Bye.
All right. We'll see you next Tuesday.
When should we be looking to the recording? Tonight?
Yeah, I'm going to see if I can't figure out how to do that now.
Thank you.
All right.
Bye-bye.
Thank you.